I would like to kick it off by giving you an overview of the COMAC project. So COMAC stands for Converged, Multi-Access, and Core. So this is a project that got ratified as a reference design and exemplar platform by the ONF board and TLT about 6 months ago. So it is one of the newer ones. In the next 30 minutes, I hope to give you some information about it. So we'll start to talk by giving a specific definition of what COMAC is all about. What is the project trying to do? And then we'll start actually pinpointing the individual components. COMAC has the word multi-access in it. What does multi-access mean from a COMAC perspective? What does convergence mean from a COMAC perspective? And why is it relevant now? Are questions that I'll try to answer. And then to achieve the convergence, well, we first need to disaggregate as much as we can. So we'll go through that process of how we actually achieve that disaggregation in a converged telecommunication network. And then we will talk about reassembly, and we'll start that with, okay, we have these disaggregated components. Let's augment the existing network with a software-defined access control. And then let's actually make sure that all of the different access technologies can coexist and live in harmony. And once we're there, then we'll start reassembling things. And we'll start with the user plane and then move on to the control plane. So you'll see where we are today with COMAC and where we intend to go in the coming months and hopefully a few years. So COMAC, as a project, has a scope of building a modular and cost-efficient platform and components with well-defined APIs to enable both access and core networks. And embedded in the project is a simple cost-efficient implementation of the 3GPP core. And that we are realizing today with OMEC. And then a converged user plane function. And this user plane function converges both the user plane functions, all of the user plane functions you might find at the edge for a cellular network, as well as a broadband network. And then a suite of control plane functions that actually intelligently control this converged user plane so that we have a seamless operation for all access technologies under question. And then the corresponding access and edge controllers that make this all happen. So this is the overall scope of the project. And as with every reference design project at ONF, there are operators who actually back these projects up. And in the case of OMEC, we have AT&T, Deutsche Telekom, China Unicom, Google, Turk Telecom, and Sprint backing whole or sometimes components of this project. And backing that up means, again, either partially or fully, the operators intend to take this to field trials. So let's start by looking at the big picture. So that hopefully is going to help us understand why we are talking about multi-access and why convergence is important. And you've seen, actually, if you were present at the panel, you've seen me use these slides in a slightly different concept. But if you think of today's operators, most of these operators are going to have subscribers via multiple access technologies. Think of AT&T. They have mobile customers as well as broadband customers. So in a simplified way, the network for an operator will look like this today. So they will have to provide coverage, a large number of base stations distributed across the geography. And the traffic from that would be aggregated towards a much smaller number of centralized locations where the core networks reside. And even a smaller subset of these are going to actually provide an egress towards the internet where today's public cloud exists and most of the OTT applications we use reside. So in this, from a cellular perspective, if an operator has not yet gone through virtualization, the core network components are going to be realized in all vertically integrated boxes. On the broadband side, the customers are going to be home premises. So you would have CPEs there connected to ONUs. And the aggregate traffic from them would actually get to the optical line terminations, the OLTs. And then again, the centralized locations, you would have sort of the core network equivalent for broadband, the BNG. Even though this is a router, it does a lot of the things that the 3GPP core network also does in terms of subscriber management, authentication, et cetera. So in this setup, the first telcos are starting to transform their networks. The first phase of this transformation, to a large extent, at least in tier 1 operators, has already happened. So that actually meant the normally vertically integrated components of the mobile core has been virtualized, disaggregated, and control plane, user plane separated. And then, followingly, in a large number of these operators, even the BNG is also virtualized. And you have telcos also providing their own services to the end users. So collectively, all these virtualized components now reside at what we call telco clouds. So this is the first phase of the transformation. The second phase actually brings the reach of this telco cloud towards the edge. And the whole idea behind that is so that we can have lower latencies, higher bandwidths, traffic localization as new business verticals and new use cases. So along with the edge, we can now start talking about RAN disaggregation. So that actually allows us to carve out a portion of the RAN, virtualize it, host it at the edge, so that it can start pooling in a truly cloud sense the remaining distributed components. But in addition to that, if we want to provide these new use cases, we want to make sure that lower latencies and traffic localizations are actualized. And to make that happen, I need to start imagining a core network that is no longer centralized, but more distributed across the geography, with a footprint going all the way to the edge, so that you can start having local breakouts. In addition to that, I need to have my applications that would benefit from an edge presence to be pushed to the edge as well. And similarly, on the broadband side, I would actually be potentially moving my BNG towards the edge too. So this takes us then to the following edge cloud scenario. So we have, before we get there though, there's one more component, which is, okay, the operators want more control over their networks, so that means they would want a software-defined control of access. So that controller needs to be in close proximity to where that access takes place. So the natural location for that controller is the edge as well. So now let's focus on this edge. This is a cloud environment on which access really meets the cloud, because we have direct access termination at the edge. But now think of the types of access termination at the edge. We have a scenario here where specifically a number of the base stations in the geography have their traffic terminations. But at the same time, we have a number of broadband customers and their corresponding optical line terminations happening at the same location as well. So then this edge is truly, for a telecommunications operator, is a multi-access edge. It needs to provide solutions for both cellular and broadband, and possibly, depending on which operator we're talking about, other access technologies as well. In addition, this is an environment where we see, if we actually start focusing on the user plane of things, where we see lots of distinct user planes. Again, for this example, we have a disaggregated RAN. So the virtualized component, CU, has a user plane function. But at the same time, we push the core network user plane function to the edge as well. So that is yet another user plane function. And last but not least, the BNG itself has a user plane function as well. At the end of the day, that's a specialized router. So now, even for this example, I have 3 user planes. They are all virtualized. So the question that we need to answer is, do we really need 3 distinct user planes? Can we actually converge them into one? What are the benefits of that? Then I can have more centralized control of my subscribers, regardless of how they connect to my services. And then the next question is, I have also a number of control plane functions here, or even maybe some going back to the central cloud. Can I actually converge those as well? Can I have a universal authentication, subscriber management, billing and charging operation across all my access technologies? So that's the reasoning why COMAC is gaining so much popularity with the operator world. Because when you actually converge these, the types of services you can start offering to your subscribers become quite immense and quite interesting.
You take questions now or you can
At the end, please. So now that we have a notion of the project, let's talk about why is it relevant now. So this is a very important question to ask, because those of you who are familiar with fixed mobile convergence will realize that this is a decade-old story. In 2004, there was a nonprofit consortium called Fixed Wireless Convergence, but it didn't survive. So if that didn't survive, why would this now? The biggest difference between then and now is the fact that now we live in an era of virtualization. So all of the components we're trying to virtualize now are all, at the end of the day, software pieces. In 2004, that was not the case. And then we also are going increasingly towards functional disaggregation. Think of the EPC. Even in 4G, we have a fully disaggregated EPC now, so that even the control plane functions are all distributed. I have a different software handling my mobility management, and another one that is my packet data gateway control. And I also have a control plane, user plane separation, at least in the cellular core network side, so that I know now that I can handle the user plane and the control plane separately. And last but not least, I have now, thanks to the increasing prevalence of the edge, I have some location, some real estate, where all of these will need to intermingle. And this new environment gives us hope that, unlike a decade ago, now we can succeed with this. So the pillars are as follows. So we are going to be looking primarily at these 2 access technologies, mobile and broadband. So on that front, at the edge, we have 3GPP core network presence. So we have at least the user plane, if not more. And then we have, in the disaggregated fashion, I have the central unit of the RAN. And then I have the BNG from the broadband access. So the whole idea is all of these potentially will go through disaggregation, and if possible, user plane, control plane separation, and so that I have these small Lego blocks that I can start thinking to fuse together. So this is an ambitious project, and potentially it's a big one. So at ONF, the ecosystem has decided to take this on in a phased way. So the first step would be to get the mobile core up to speed from an open source perspective. So that means focusing on OMEC first. So taking that to field trials, making sure that we have a stable foundation. And then the next phase would be to zero in on the platform itself. So we need a platform where actually we can showcase that both mobile and broadband solutions can coexist and share the same infrastructure and share the same cloud management system and share the same SDN control. And once we are there, then the next phase would be to start discussing the user plane convergence. So there specifically, we will be looking at the RAN CU user plane, the EPC or the core network user plane, and the BNG user plane convergence. And the last phase then is going to take us to control plane convergence. So we are going to start discussing, can I converge the authentication or subscriber management, et cetera? Which ones can I converge and which ones will have to remain distinct? Those decisions to be made. And once we're there, then we will have effectively a platform where, to a large extent, all of these components are going to be converged, and we'll call that COMAC. So with that, the first phase, as I mentioned, is disaggregation, right? So let's actually have our terminology correct. So those of you who are in mobile networks will immediately know that we call the access, the RAN, the access, and the mobile core, the core. But from the broadband perspective, their equivalence would look something like this. The home premises plus the ONU and the OLT, I can call that the broadband access, and I can call the BNG to be the broadband core. All right? So let's decide on that terminology first. Now, once we make that decision, let's start disaggregating things. So we start from the cellular side. So the first thing we do is we start from the core, and we do a CUPS disaggregation. So the user plane and the control plane are disaggregated. Further, we go towards a functional disaggregation. So I can define the control plane made out of different components. Next, in the same fashion, I have gone through the RAN disaggregation, if you notice here. So I have a radio unit, which is at antenna sites, distributed unit at cell sites, and my CU, the central unit, residing at the edge. The next is actually taking the virtualized component, the central unit, and doing a CUPS separation for that as well. So I have a CUU and a CUC. All right. Next is we start looking at the broadband access. So the first thing that I do is do a CUPS disaggregation of the BNG. So I have a user plane function and a control plane function. The next one would be the functional disaggregation. So for that, that would mean I would start realizing the control plane function as address management, subscriber access management, the AAA, and service control, et cetera. All right? So once I'm there, then the next phase, if you recall from my introduction, is integration with programmatic access. So from the broadband side, what we do is we start realizing the OLTs as white box programmable entities. And through a hardware abstraction, we can use then ONOS with an appropriate application to programmatically control my OLT. But similarly, on the cellular side, I can actually use ONOS. You have heard probably me talk about this in the morning. And with the appropriate add-on to the ONOS, I can turn that into an SD-RAN control and add different RAN control applications on it and turn my RU and DU into programmable entities. Then we have to enable coexistence. So we need then a common platform, and by that common platform, I mean the same cloud management platform, like Kubernetes, for example, the same hardware that in a multi-tenant fashion, these access technologies share, and the same SDN control and the same fabric, clearly, that host all of these together, and both base stations and home subscribers are terminated at the same location. So this would be the first step in the first big milestone in COMAC. Once we are there, then we'll also start re-aggregating. So the first thing to re-aggregate would be the user plane function. So we'll call that a converged user plane function. So that converged user plane function will include the user plane of CU, the gateway user plane, as well as the BNG user plane. Then effectively, I have a user plane function that will need control from three different entities, right? The 3GPP core network control, the RAN control, and the BNG control. So then I need an intelligence here so that based on exactly what packet comes in, it knows which control entity to ask. Moving forward, you've heard this morning a great talk by Nick McEwen and P4. So if I have a converged user plane function, why would it not be possible to realize that as a P4 program so that I can realize it right on my fabric? And that takes us to the realization of the converged user plane function as a P4 application and an ONOS instance controlling it using P4 runtime. Then we'd start talking about converged control plane. So then all of the control plane functionalities, clearly mobility management is distinct to one access technology. So we're not talking about convergence there. But all of the rest are open questions for convergence. So can I do a converged authentication? So here, with each and every one of these, actually, there is work ongoing between 3GPP and Broadband Forum to see different levels of convergence. And we would be actually, based on the outcome, we would be leveraging that work to make this happen moving forward. So the ultimate platform then would look something like this. I would have a white box leaf spine fabric at the edge, a number of commodity servers, and on that I would have a cloud management platform on which I realize my converged core control plane. And then the user plane actually is realized as P4 running on the fabric. And then the SDN control deals with access control, it deals with the user plane control, and it also deals with the fabric control. All right, so this takes me to our release. So like I said, within the ONF ecosystem, the work on COMAC has started about 6 months ago. So we're at a phase where, if you think of the staged approach, we have had a good head start on OMEC. So the mobile core, as you've heard me numerous times, at least the gateways are going through significant hardening. So we are at a much better place than we were before on that front. And those of you who have not seen our demo, please go see. So with next week's release, we have now the beginnings of a platform that can host both broadband and mobile in one platform. If you were to ask me, I could say we are somewhere halfway done with phase 1, and we're halfway done with phase 2, because the 2 phases we are pursuing in parallel. And this is actually quite a change for us, because in the past, MCORD has been around for a number of years, and you've probably heard or seen us do some great demonstrations at MWC or ONS or here, ONF Connect. But those have been all about cutting edge technology, and our whole focus was creating demo quality work with our goal being, okay, let's have a great demo. But now, with this release that we are about to have next week, we have actually the foundations of a field triable solution. So we're basing the baseline on the foundational, already hardened platform that another project at ONF's, namely SIBA, has developed. So we share the same common platform here. So in addition to that, we add OMEC, and then the corresponding FCAPS capability for mobile subscriber state information, and the SD-RAN. So all of these are at different levels of maturity, but hopefully once we have this first release, with every subsequent release, we are going to get closer and closer to a field trial solution. All right, so thank you. Questions, yes?
So, until now, I haven't seen a convergence between the BNG and the mobile core. So
Not yet.
okay, so they're co-located, but they're not converged.
Exactly. So the convergence work is yet to start. So to be able to start talking about convergence, first we need to have stable virtualized components that are disaggregated the way we want them to. So the SIBA work that is running in parallel is just starting to tackle the BNG virtualization and disaggregation. So once they're actually making some headway, and once our OMEC project gets to a certain stage, then we'll start talking about convergence.
So, but convergence also means significant change in the way networks are being managed.
Correct.
Because there are two different entities.
Yes,
Different cities.
absolutely.
So do you see that coming from carrier side, that they are willing to change the way they are?
Don't forget, these are all our projects. If an ONF project is designated as a reference design and exemplar platform project, then the operators who are backing it back it with the understanding to take it to field trial with potential production networks. So yes, all operators fundamentally want this.
Do you see the user plane and the control plane converging at the same time?
No, I personally, yeah, I personally see it being in stages. So it would be user plane first, I would imagine.
Because we have to do
The control plane would come much, much later, I would say. I mean, that's a bigger, much bigger problem.
And I have another question because you're talking about like certain elements from the core moving to the edge. Is that for performance reasons or why would you?
Yeah, I mean, for certain business verticals, you may want to do that. Not for everyone, but for certain business. I mean, if you, if you want an enterprise solution, you will want that user plane, a user plane function to be local because that enterprise might want its data to stay there.
Right, so you're talking about like sort of isolated.
Again, that's, now we're talking about business cases. So it's all entirely based on the operator business cases. So different operators will approach it differently.
Because you also talk about the SDN moving to the edge too, right?
For the RANs and broadband access control, yes. So you have to find a good balance. That's a great question. So it's all a matter of money at the end of the day, right? So this is effectively, we're turning the network into a distributed network cloud. So as with every cloud, there is this pooling versus price. The whole thing in a distributed fashion will need to take place here. So effectively, workload placement and monetization is going to come hand in hand. So you need to do optimizations there.
But it won't be like as if you're going to take any workload from the cloud to the edge. You may want
Yes.
some workload to stay locally.
So you mentioned that the first step for COMAC is like creating this open source mobile core,
Yes.
which is in itself a pretty large undertaking.
Yes.
How up to date do you envision that mobile core needing to stay with like as operators push towards like service-based architecture, cloud native functions? Like how much of your production time is keeping that mobile core up to date or on track with that versus like?
Excellent question. So OMEC on its own is a distinct project within ONF. So in its own mission, it is going to evolve towards 5G core and cloud native. Now, when actually COMAC picks it up for convergence, again, we're going to end up looking at our operators so that they can let us know when it makes sense to start thinking about convergence.
Question. If you see a lot of operators are invested in OpenStack, which is the NFV infrastructure, and they go to OMAC or COMAC, you're thinking that they have to forklift their infrastructure or the orchestration and the management of all the infrastructure from existing OpenStack and go to Kubernetes-based technology?
Again, an excellent question. So first things first, OMEC as a standalone project is not bound to Kubernetes. So you can actually realize every component either on bare metal or on VMs or on containers. It would work either way, okay? So with regards to the platform being Kubernetes-based, we have done that migration consciously at ONF a while back. And when you look at the other projects like SIBA, that is actually entirely container-based. It's Kubernetes. So the reason for that is simple. At the edge, you want to be as nimble as possible following up. And a container-based solution has a smaller footprint than a VM-based solution. So we saw the future there, and that's why we made that move consciously. But having said that, if an operator really insists on a VM-based solution, a prior release of Cord actually had Kubernetes and OpenStack running side by side. So you can have a hybrid solution as well.